sequences and series, all the formulae that you need. Okay, arithmetic sequence. An arithmetic sequence is a list of numbers where consecutive terms are calculated by adding or subtracting a constant value to the previous term. Okay, so we call this constant value the common difference. Okay, so the constant value which is added or subtracted to calculate consecutive terms, this is called common difference. Okay, so the general formula to find any term of an arithmetic sequence is, okay, we use this. This is the general formula to find any term of an arithmetic sequence. Okay, to find T1, T2, T3, any term of an arithmetic sequence, we use this formula. Okay, so this is the general formula. So Tn is the nth term. So Tn represents any term of an arithmetic sequence. It can be T1, T2, T3, T4, any term of an arithmetic sequence is represented by Tn. Now, A is the first term, T1. Okay, T1. Now, D is the common difference. The constant value which is added or subtracted is known as the common difference. We use D to represent the common difference. So to find the common difference, okay, to find the common difference, you always take the next term minus the previous term. Okay, next term minus the previous term. This is equal to the common difference. Okay, we are going to see that. So now n is the position of the term in the sequence. So it can be T1, you are going to have 1 in place of n. If it is T2, you are going to have 2 in place of n. If it is T3, you are going to have 3 in place of n. So n is the position of the term in the sequence. Okay, so for example, if you are given an arithmetic sequence as this one, now the difference, you have to take the next term minus the previous term. Okay, 5 minus 2, you are going to have 3. 8 minus 5, you are going to have 3. 11 minus 8, you are going to have 3. 14 minus 11, you are going to have 3. Okay, so you always take the next term minus the previous term. Okay, so Tn minus 1. Okay, so you have this. This is your common difference. From this example, you know T1 is equal to 2. Okay, T1 is A. A is T1. Okay, T1 is equal to A, and in this example, T1 is 2. Okay, the first term. Okay, T1. And T2, in this example, T2 is equal to 5. T3 is equal to 8. T4 is equal to 11. T5 is equal to 14. And the common difference, okay, the common difference is equal to 3. Okay, now arithmetic series. An arithmetic series is the sum of the terms in an arithmetic sequence. We are going to see that. The general formula to calculate the sum of an arithmetic series is, you can use this formula or this formula to calculate the sum of an arithmetic series. Okay, we are going to see that. So Sn is the sum of nth terms. Okay, so Tn represents any term of the sequence. Okay, it can be T1, T2, T3, and so on. Now, Sn represents the sum of nth terms. Okay, we are going to see that. Now, A, okay, A is the first term, T1. Okay, A is the first term, T1. Now, D is the common difference. Now, N is the number of terms. Okay, when you have the general formula to find any term of an arithmetic sequence, N represents the position of the term in the sequence. Now, in this case, N represents the number of terms for which we are calculating the sum. Okay, we are going to see that. Now, L, you have L in this formula. Okay, in this formula, L represents the last term of the sequence. We are going to see that. Let's see an example. An example of an arithmetic series. I'm going to use the same numbers. Okay, in the case of a series, I have plus. Okay, a series you add. For a sequence, you separate using a semicolon. Okay, you separate. For a series, you add using plus. Okay, for a series. Okay, so the difference is still 3. Now, A, which is T1, is equal to 2 in this example. Okay, and the difference, the common difference is 3. So, for example, if you are calculating S4, you are going to calculate the sum of the first 4 terms. Okay, 2 plus 5 plus 8 plus 11. You are going to have 26. Okay, you are going to have 26 for S4. Okay, so you understand N represents the number of terms for which you are calculating the sum. Okay, now another example of an arithmetic sequence. Okay, so you can have something like this. Now, in this example, you have the first term and the last term. Okay, so the difference is always next term minus previous term. Okay, 1 minus 3. You are going to have 4. Okay, 1 minus 3. You have 4. Now, 5 minus 1, you have 4. So, you have a common difference constant. Okay, so from this, A is equal to negative 3. A is your first term, and you have L in this example. Okay, L is equal to this, the last term. So you have negative 3, 1, 5, and you have terms in between until your last term. Now, in this example, the common difference is equal to 4. So this is what you have to know about arithmetic sequence and arithmetic series. Now, geometric sequence. A geometric sequence is a list of numbers where consecutive terms are calculated by multiplying or dividing the previous term by a constant value. Okay, so we call this constant value the common ratio. Okay, not the common difference. Now we call the constant value the common ratio. So the general formula to find any term of a geometric sequence is, okay, we use this to find any term of a geometric sequence. Okay, to find T1, T2, T3, T4, and so on. Okay, so this is the general formula to find any term of a geometric sequence. Okay, and Tn is the nth term. Tn represents any term. It can represent T1, T2, T3, T4, and so on. Okay, any term of a geometric sequence is represented by Tn. Okay, so Tn is the nth term of the sequence. Okay, and A is always the first term, T1, and R is the common ratio. Okay, the constant value is known as the common ratio. Okay, we use R. So to find the common ratio is equal to, you take the next term over the previous term. Okay, this is how you can find the common ratio. Okay, we are going to see that. Now, N is the position of the term in the sequence. So if you are calculating T1, N is equal to 1. If you are calculating T2, N is equal to 2. If you are calculating T3, N is equal to 3. So N is the position of the term in the sequence. Now, let's see an example of a geometric sequence. Okay, so you can have something like this. Which constant value is used to find consecutive terms? So from 1 to 2, there is multiplication by 2. 1 times 2, you have 2. From 2 to 4, there is multiplication by 2. Okay, 2 times 2, you have 4. From 4 to 8, there is multiplication by 2. From 8 to 16, there is multiplication by 2. So you can see, to find the common ratio, you always take the next term over the previous term. Okay, so 2 divided by 1, you have 2. 4 divided by 2, you have 2. 8 divided by 4, you have 2. 16 divided by 8, you have 2. Okay, so you can take any next term over the previous term to find the common ratio, R. Okay, so in this example, T1, which is equal to A. Okay, T1 is A. In this example, T1, which is equal to A, is equal to 1. Okay, T1 or A is always the first term. This is 1 in this example. Okay, and T2 is equal to 2. T3 is equal to 4. T4 is equal to 8. T5 is equal to 16, and so on. And the common ratio is equal to 2. Okay, the constant value which is used to find consecutive terms. Let's see about geometric series. Okay, a geometric series is the sum of the terms in a geometric sequence. The general formula to find the sum of a geometric series is, you can use this formula or this formula. Okay, so this formula and this formula is the same thing. Okay, you can see, let me show you. If you multiply the top part by -1, you are going to have this. Okay, you are going to have this. If you multiply the bottom part, the denominator, okay, the denominator, if you multiply the denominator by -1, you are going to have this. So can you see, -1 over -1, this is equal to 1. So you are multiplying everything by 1. You're still going to have the same thing. Okay, you can use this formula or this formula to find the sum of a geometric series. Okay, so R, the common ratio, is not equal to 1. You have to see that if R is equal to 1, you are going to have 1 minus 1. So you have division by 0. Okay, if R is equal to 1, you are going to have 1 minus 1. Okay, division by 0. So division by 0 is undefined. Okay, so R is not equal to 1. Okay, you understand. Now, Sn is the sum of nth terms. Now A, okay, A is the first term, T1, and R, now R, okay, R is the common ratio. Now, N, in the formula for calculating the sum of a geometric series, N represents the number of terms, okay, which is different in this formula. In this formula, N is the position of the term in the sequence, okay. In this formula, N is the number of terms, okay. We are going to see that. Now, an example of a geometric series, I can still use the same numbers. You are going to have this. Now, you have to see the difference. For a geometric series, I've got plus, okay. I've got plus for a geometric series. For a geometric sequence, I've got semicolons to separate my numbers. And for the common ratio, you still have 2, the common ratio, okay. To find the next number, you multiply by 2, okay. 2 is the common ratio. Now, the first term, okay, A, which is T1. In this example, A is equal to 1. Now, the common ratio is equal to 2, which is the same as in this example because we have the same numbers. Okay, so the common ratio is equal to 2. So now, N is the number of terms, okay? In this formula, N is the position of the term in the sequence, okay? So, if, for example, you are calculating S3, it means you are calculating the sum of the first 3 terms. You are going to have 7, okay? 1 plus 2 plus 4, you are going to have 7. So S3 is equal to 7. If you are calculating S4, it means you are calculating the sum of the first 4 numbers, okay? If you are calculating S4, it means you are calculating the sum of the first 4 numbers. S4 is equal to 15, okay? 1 plus 2 plus 4 plus 8, you are going to have 15. So you understand, N is the number of terms, okay? Not the position of a term in the sequence. In the case of this formula, N is the number of terms, okay? So you have to see the difference, okay? Now, the sum to infinity of a geometric series. Let's see. The sum to infinity of a geometric series can be calculated if the geometric series converges, okay? This is what we use for sum to infinity, okay? For sum to infinity, you have the infinity symbol, okay? You have the infinity symbol, okay? This, okay? So, you have the first term over 1 minus the common ratio, okay? We are going to see that. So, S infinity stands for sum to infinity, and A is always the first term, T1, and R is the common ratio, okay? The common ratio. Now, R is not equal to 1, okay? So that we don't have division by 0. For a geometric series that is convergent, R is in between -1 and 1, okay? For a geometric series that is convergent, the common ratio is in between -1 and 1. So, a geometric series converges if R is in between -1 and 1. So, a geometric series converges when Tn tends to 0 as n tends to infinity. We are going to see that. So, you can have something like this. This is an example of a convergent geometric series. this geometric series tend to 0. Okay, you can see. You are going to see. Can you see 1 over 8 is equal to 0.125. Okay, 0.125. This is 1 over 8. Now, 1 over 16, 0.0625. Okay, we are getting closer and closer to 0. Okay, 1 over 32. This is equal to 0.03125. Okay, you can carry on. 1 over 64. This is equal to 0.015625. Okay, we are getting closer and closer to 0. So the terms are reducing. We're getting closer and closer to 0 as n tends to infinity. Okay, we are going to infinity. This is n equal to 1. This is n equal to 2. This is n equal to 3. This is n equal to 4, because this is the first term, the second term, the third term, the fourth term, and the fifth term. N is equal to 5, and this is n equal to 6, because this is T6. Okay, so n tends to infinity. So a geometric series converges when Tn tends to 0 as n tends to infinity. So when you check between 1 and 1 over 2, there is multiplication by 1 over 2. Okay, 1 times 1 over 2, you have 1 over 2. Now, between 1 over 2 and 1 over 4, there is multiplication by 1 over 2. Okay, 1 over 2 times 1 over 2, you have 1 over 4. Between 1 over 4 and 1 over 8, there is multiplication by 1 over 2. Okay, and so on. 1 over 2. Okay, so this is the common ratio, which is constant. Okay, the common ratio is 1 over 2. You can see 1 over 2 is equal to 0.5. 0.5 is in between -1 and 1. So you understand this is a geometric series that is convergent, because the common ratio is in between -1 and 1. So this is how you can check to find out if a geometric series is convergent. Okay, so for a divergent geometric series as this one, you can see the numbers are increasing. So you cannot calculate the sum to infinity of a divergent geometric series, because Tn gets larger and larger as n tends to infinity. So the sum to infinity of a divergent geometric series does not exist. Okay, now for a divergent geometric series, r is less than -1 or r is greater than 1. Now, quadratic sequence. A quadratic sequence is a list of numbers in which the second difference between any two consecutive terms is constant. Okay, so the general formula to find any term of a quadratic sequence is, you are going to use this formula. Okay, Tn is equal to an squared plus bn plus c. You can use this formula to find T1, T2, T3, T4, and so on. Okay, so this is the general formula to find any term of a quadratic sequence. Okay, so let's use an example to understand quadratic sequences. So you are given this quadratic sequence. Okay, now the difference, you always take next term minus the previous term. Okay, 13 minus 6, you have 7. Okay, next term minus previous term, always 25 minus 13, you have 12. 42 minus 25, you have 17. 64 minus 42, you have 22. So you can see the difference is not constant. So this is our first difference. The difference is not constant. Okay, you have 7, 12, 17, 22. Okay, so a quadratic sequence is a list of numbers in which the second difference between any two consecutive terms is constant. So let's find the second difference. Okay, this is the first difference. Now the second difference, you always take the next minus the previous term. So 12 minus 7, this is 5. 17 minus 12, 5. 22 minus 17, 5. Okay, so this is the second difference. You can see the second difference is constant. Okay, 5, 5, 5. This is constant. Okay, the second difference is constant. Now, always remember, use these numbers. Okay, these numbers. So this will always be equal to 2a. Okay, whatever you have there will always be equal to 2a. Now from this, you can solve for a. Okay, and this number will always be equal to 3a plus b. Okay, whatever you have there will always be equal to 3a plus b. Okay, and this number, whatever you have there, will always be equal to a plus b plus c. Always, this, whatever you have there, will always be equal to 2a. You can solve for a, and then whatever you have there will always be equal to 3a plus b. Okay, after you have a, now you can solve for b, and whatever you have there will always be equal to a plus b plus c. Okay, after solving for a and b, now you can solve for c. So this is how you can solve for a, b, and c from the general formula. So 2a is always equal to the second difference, and 3a plus b is always equal to t2 minus t1. Can you see? This is equal to t2 minus t1. Let me show you. This is t2, okay, and this is t1, okay. This is t1, this is t2. So t2 minus t1, you have this, okay. Can you see? So this is t2 minus t1, which is equal to 3a plus b. So 3a plus b is always equal to t2 minus t1, as you can see. And a plus b plus c is always equal to t1. Okay, this is t1. Okay, always use these numbers. Okay. Now, let's learn about sigma notation. Let's use an example as this one. This is sigma symbol, a Greek letter. This Greek letter stands for sum of. Okay, the Greek letter stands for sum of. So, whatever you have in front of the sigma symbol will be the general formula. Okay, the general formula is in front of the sigma symbol. The general formula will give you the expansion or the series. We are going to see that. Now, after you get the series, now you'll be able to tell what type of series you are dealing with. So, depending on the type of series, now you have to decide if you are going to use arithmetic formulae or geometric formulae. Okay, you have to get the expansion or the series first so that you can decide if you are going to use arithmetic or geometric formulae. We are going to see that. Now, whatever you have below the sigma symbol. You are going to use it. You plug it into the general formula, and then you are going to get your first term. And whatever you have above the sigma symbol, plug into the general formula what you have above the sigma symbol, okay, above the sigma symbol, to find the last term. So, to find the first term, you plug what you have below. To find the last term, you plug what you have above. And in front of the sigma symbol, you have the general formula. Okay, the general formula will give you the expansion or the series. Now, after getting the series, you are going to decide if you are dealing with arithmetic or geometric. Okay, let's use an example to understand the sigma notation. Okay, let's use an example to understand the sigma notation. So, we are going to use this. To find the first term, you have to plug k is equal to 1. Okay, let me show you. Let's say, for example, you have -2. Okay, -2 below the sigma symbol. So, -2 will be plugged to find the first term. And then to find the second term, you plug -1. To find the third term, you plug 0. To find the fourth term, you plug 1. To find the fifth term, you plug 2, and so on. Okay, if k is equal to -2, but in this example, k is equal to 1. So we have to start from 1 and then 2 and so on. Okay, so this is a shorthand notation. Let's find the expansion or the series. So this is equal to, you plug 1, you have this. Okay, you plug 1 wherever you have k. You have T1 plus. Now you are going to plug 2. After 1, you have 2 plus. Now you are going to plug 3 wherever you have k. Okay, so this is T1, T2, T3. Okay, let's find the last term. Okay, so plus, you have terms in between, plus. Now the last term, you are going to plug 35. Okay, plug into the general formula what you have above. Okay, above the sigma symbol to find the last term. Okay, you have 35. You are going to plug 35 into the general formula so that you have your last term. So this is equal to, this is 3 plus 16, 19 plus 6 plus 16, 22, 9 plus 16, 25, plus you have terms in between, plus now you have, this is equal to 121. Okay, so you have your expansion or your series. Okay, so this is the shorthand writing of this. Now, from this series, you can see you have a common difference of 3. Can you see? 22 minus 19, this is 3. 25 minus 22, this is 3. You can see you have a common difference. So you understand you are dealing with arithmetic, not geometric. Okay, when you have a common difference, you know you have an arithmetic series. So this is an arithmetic series because there is a constant difference. Okay, so you have to think of this formulae. Okay, so we have to find the sum of using this formula or this formula. Okay, so we have to find the sum of how many terms. You have to find n. How many terms are you calculating the sum for? You have to find n. So to find n, you are going to take whatever you have above the value above the sigma symbol minus the value you have below the sigma symbol plus 1 always. So n is equal to, you have 35 above minus you have 1 below, okay, plus 1. This is equal to 35. You can also find n this way. Since you are dealing with an arithmetic series, you can use this formula to find n. Okay, you are going to use the last term to find how many terms you have to calculate the sum for. So you are going to find how many terms you are calculating the sum for. So let's plug 121 in place of Tn. This is equal to A is equal to 19. Remember, A is always the first term, okay? Plus, in bracket, n minus 1, okay, times d. D is the common difference, which is 3, okay? From this, you can solve for n. You are going to find n is equal to 35. So, you have two ways that you can use to find n. Okay, now we know we have to calculate S35. Okay, S35. You can use this formula or this formula. I'm going to use this formula. So, this is equal to 35 over 2. In bracket, I have A, which is 19, plus L, which is the last term. Okay, 121. You close your square bracket. So this is equal to, you can use your calculator. Okay, so this notation is equal to this. Okay, we are done.